Hey everybody, welcome to the second video in our little mini lecture series that I do not have a name for, so please feel free to suggest something. I was going to call it the problem solving series since most of these are going to be focused on tips for solving problems, but some of them are just general physics success tips, so I don't know. Any suggestions would be useful. So so I'm here again with my lovely companion, a picture of my dog Howitzer because he is a husky and a psychopath who's sleeping downstairs. But he's very cute, so I put him on here to give you guys some eye candy. A cute little white husky. So like I said in the last video, this video we're going to be covering a problem-solving mnemonic, which should be helpful for especially getting started on this first section. So if you're struggling to get started on a physics problem, I would suggest using the GUESS method. And GUESS, like I said, is a mnemonic, and that stands for givens, unknowns, equation, substitute, and solve. So what this means is that if you're, I don't want to use the word given, but if you're looking at a problem, one of your homework problems, the first two steps that you want to be able to get from your problem is to A, identify the givens that you have. So what information are they giving to you? What do you know right off the bat just from reading the problems? You want to identify your unknowns and mainly what the problem is asking for. Then you're going to want to look at your list of equations that you have from your lecture notes, which I'll just give the hint now. So the next video is going to be all about writing out your own personalized equation sheet because I have found it very helpful in the past when taking physics to kind of summarize just the equations and maybe a little blurb about what they mean while I do my homework, just so all the equations are right there and I could kind of quickly go back and forth. And you will have an equation sheet on your exam that one will be provided to you, but still it helps to I think it helps to get through the problems. And it will help for this because if you have your equations all kind of neat and organized and laid out on a separate piece of paper, then once you have your givens and your unknowns, you can look through your equation list and see if there's one or a couple that link your givens to your unknowns. Once you find that equation, you substitute in the values that you have into that equation, and then last step, solve, is that you're going to solve the equation for your unknown, and then you get your answer. So let me go to screen record on the pad, and I'll go through a simple example of how we might use something like this. So we have a sprinter is at the 10-meter mark when they reach a constant velocity of 4 meters per second. How long does it take for them to make it to the 100-meter finish line? So we'll have our givens. Oh God, that's terrible. That's better. So we have our givens. So we'll have our initial position, x0 is 10 meters. Our velocity is going to be 4 meters per second. And our final position is going to be 100 meters. And now our unknown is going to be the time that it takes to do that. And now the equation that we want to use is going to be just the kinematic equation for constant velocity. So I apologize if this isn't the notation that you guys are using in your book, but it will be the final position is equal to the initial position plus
the velocity times time. So now we will substitute. So our final position was 100. Our initial position was 10 plus 4t. And now we will solve for t. So first thing we're going to want to do to get t by itself is to subtract this 10, which I'll do in a different color. So we're going to subtract 10, which will give us 90 equals 4t. And then we'll divide out that 4. 90 divided by 4 will be 22.5 seconds is our time.
Howitzer, you want to catch? You ready? You ready? Oh! Say bye to the kiddos.